Okay, one more thing. So I want to go over a couple things, answer your questions, and then jump into some of these math team topics that we're talking about. These problems are not easy. Okay, some of them actually aren't bad. Some of them are like, what in the heck? I have two kind of math team worksheet level things. One of them says logarithm problems for math team test. The other one says more. When I give you the one that says more, I'm going to be repeating probably a lot of the ones that are on here. That's what I would focus on your test. There are some problems on here that are like 1 in a million. It's really got a little logarithm to it, but it's mostly just ugly. It's just Vestavia or Hoover just trying to hurt you and take away your man or womanhood. But the reality of it is, we can do a lot of these, all right? And remember, when you're doing these, don't just assume the position. We talked about that, right?
Yeah.
We're not going to assume the position. We're going to assume that the person writing this question is trying to take a very small language that only has a couple rules, and they're trying to tweak it in a way that intimidates you. So don't be intimidated. Assume that you do have the skills to put this together, okay? And if you could just get through usually the first door, right? Or just part the clouds a little bit, the sun shines down on the problem, all is revealed, and you're going to be good. Now, that's not always the case, but assume that, because a lot of these problems, the first thing you look at, you're like, oh my gosh, I don't even know what to do. Okay? But here's what I want to do. Before we jump into here, I want to talk about a couple things. So the first thing I want to talk about is, can you multiply logarithms? Have I given you any ability to multiply logs so far? No. But there is a way under special circumstances that you can. Okay? And you really almost have to be lucky, but let me give you an example. And math team questions love to give you these kind of problems. Like, what if I said, what is log base 2 of 3 times log base 3 of 4 times log base 4 of 5 times ... and log base 255 of 256. So this is a math team kind of question, and no, I have no rules for multiplying. But yesterday we talked about something called the change of base rule. And if you remember, the change of base rule said if you have a single logarithm with just some random base and you're logging some other random number, that if you want, you can rewrite it as a fraction of 2 logs with any base you want. And this is, I think I mentioned, this is how I used to evaluate logs, because I didn't have a calculator that did base A. I only had a calculator that did base 10 or base E, the ln. You had in your homework last night, right? So what I had to do is I had to write this as log of whatever base I want. I'm going to pick base 10 of B, and log of whatever base I want that matches this one. Again, I'm picking 10 of A. And this is the same as this. Well, the advantage in situations when you're multiplying is if I did this, it gives me an opportunity to maybe start canceling some stuff. So you can see on this, I get log 3 over log 2, if I rewrite this one, right? This one gives me log 4 over log 3. This one gives me log 5 over log 4. And then if the pattern continues, I end up with log 255 of 2, I end up with log of 256 over log of 255. Are y'all with me so far? Now, what do you see now that just happens to cancel?
Everything.
So those cancel. Those cancel. Can I assume that the next one's going to be log 6 over log 5 if the pattern holds? So they would continue to cancel like this. Can I assume the one right before here would be log 255 over log 254? If the pattern holds, right? So all I have left is what? Over the log of 2. And now, can I take, I have 2 options here. Can I take this and change it back to a single log by doing going this way. So what would that give me? And since 256 happens to be 2 to the 8, then this is equal to 8 over 1. And that's all day long at a math tournament. Now you don't have to go back to this. You could say, like I'm just going to head this way. You could say, well, log of 256 is log of 2 to the 8th, right? Over log of 2. And then what could you do with that 8? Based on the rule that we've learned, right? You can swing that 8 to the front, and once it's to the front, what happens to those log 2's? They could cancel, leaving me an 8. So it's either way. You can head that way with your mentality or head that way with your mentality. But the nice way of heading this way is, if it didn't simplify, you'd at least have it in one log form. Like, for instance, if that had been like a 129 or something that didn't simplify, you could rewrite it as log base 2 of that, and if it doesn't simplify, you could stop. But because it does simplify, we continue. Y'all seeing that? So that's a problem that you might see. So anytime you see multiplication, don't try to go, oh, well, to add logs, I multiply, so to multiply logs, maybe I add. There is no way to multiply unless you're just lucky. So most of the time, like if I said, hey, multiply log base 3 of 5 times log base 7 of 12, well, it's not going to help me to do anything. Like this, even if I do change of base, I mean, I can't cancel anything. So I really can't multiply unless I'm just really lucky, and it's not really luck, it's because the problems were created for this kind of thing to happen. Y'all seeing that? But that's your only hope, is change your base rule and then getting lucky and canceling stuff. And then there was another problem that you might have, do y'all remember a problem like this on your homework? There was one in there, I'm pretty sure somewhere like that. I don't know if it was that long.
Our homework last night?
Your homework at some point. I haven't taken it up because I've been telling you to skip it, but to go back and redo those problems that you don't know how to do. At this point, we've done everything, so you should be able to go back. If you don't do that, I think you may be hurting yourself. Unless you just completely dominate on this math team level stuff, you probably need the practice of the problems that you skip. Okay?
That one's in like the more problem. I just looked, it's in like the problems.
Yeah, it's in this one that we're about to do today, and it's in the more one. There's definitely stuff like that. In fact, the very first one on this list isn't a pattern like this, but it's going to be solved the same way. But here's another one. Sometimes you'll see something like, and this is not really brutal. Let's try this. Sometimes you'll see these with like 7 logarithms. Like the log base 5 of something, log base of something, and they'll have all these logs piled up. How do you think you start? How have you ever started when you want to get rid of a log? Exponentiate? What would you start with then? You'd start with this. So if I exponentiate with the base 5, I'm basically saying 5, I'm basically thinking like this. 5 raised to this ugly exponent is equal to 5 to the 0. That's your thinking. And when I do that, what happens on the left? 5 log 5 cancels, and you're left with log base 3 of log base 2 of x equals what? 1. All right? And then, what do you do now? Exponentiate again. So 3. So you're basically saying 3 to that power equals 3 to the first. And again, logs cancel. Now you're left with log base 2 of x equals 3. And then, exponentiate with the 2. 2 log 2 cancels. X equals 2 cubed, which is 8. And 8 does work out here. But you would see it with maybe 7 logarithms. So you're just going over and over and over and over your exponentiate. Y'all seeing that? Another problem that you saw might have been something like this, and these get a little nasty. Simplify. Now you have a rule, right? It says 3 log 3 would cancel as long as those match. But the problem is these don't match, do they? Could I make them match? Has anybody got anything crossing through their brain right now that might help? Okay, so let's start with that. That's 5 cubed, that's 5 squared. Let's just see what happens. So I have 5 cubed there, and I have log of 5 squared of x. So this makes me think that you're trying to get to just 5s right there. Now if I'm trying to get to just 5s right there, that's great, but that means that 2 must go and that 3 must go.
Bring the 2 out and make it 1.
Okay, so you learned a rule that said if I have a power there, I can swing it to the front and do 1 over that power, right? Right? So if I wanted to, that 2 can come out front. Did you also learn that if I have a power right there, I could make it a 1 over m up top? Do you remember that rule? Because a 1 over m here can be swung up there. So if it were me, I can move that 2 and make it a 1/2 out front. That's fine, but since I want to move it up here anyway, I'm probably going to take that 2 and make it a 1/2 right there. Now what do I have to deal with? Okay, so power to a power multiply. So that gives me 3 log 5 of x to the 1/2. But the 3 is still in the way because my rule says you have to have a 1 right there to be able to cancel.
Wait,
Oh, but you can swing the 3.
So you swing the 3 up, and 3 times 1/2 would be 3/2.
wait, how, so the rule is you can just put that 3 in front of it?
Well, you have a rule that says power to a power multiply powers. And if that's a power and that's a power, multiply them. That's where I got that from. That times that. Power times power. Right? And then I swing the 3 up where the 1/2 already is, and that gives me 3/2. And at that point, you're kind of good, aren't you?
Yes.
So, cancel the logs, and you're left with x to the 3/2 power. Let's look at another one. And believe me, you will see all sorts of ugliness in a math tournament with these. But once you kind of get the hang of them, they're really not overly brutal. What about 8, 5 log base 16 of a? Again, I'd love to cancel like x log x or 3 log 3 or like I did here, 5 log 5, but I got all kinds of stuff in the way. So anybody got any ideas?
We got 2 cubes and 2 to the 4.
Okay, so if I changed 8 to 2 cubed, then I would have 5 log base, and you said change 16 to 2 to the 4th, so log base 2 to the 4th of a. So I want to have 2 log 2, but I got a lot of stuff in the way. So anybody got any ideas?
Put that 4 above the A, make it 1/4.
So this 4 can become a 1/4.
And that 3 can go up to the,
Well,
Take that 5 and
yeah, let's
swing
say
it up.
What's that going to end up being when I do power to power?
15.
15?
And
So why don't I just take that 15 and move it up?
15 over 4.
You get 15 over 4, and now I have 2 log 2 of a to the 15/4. Your log rule comes into play, a to the 15/4.
Wow.
Are you seeing these? And believe me, I'm just getting started. These are like basic ones. I can put fractional exponents, negative exponents. I mean, there's all kinds of weird stuff, but do you have the basic idea? Aside from this, it just ends up being ways to try to make it look uglier to you, to get you to tuck tail and run, but we're not going to assume the positions, right?
Yeah.
We're going to be like a rat in a maze, and we're going to sniff around for the cheese, and at some point we're going to catch a little wind, and we're going to head to the finish line. But if you just go, oh my gosh, what the heck? You're going to be hurt every time by I'm going to say simple, But so many times at these math tournaments, or on my test, I give a problem like this and people just bail because they can't just get past that first door. In fact, you know what? There was one year, Vestavia, I remember, usually their 25th question on the test is just brutal. I mean, they really do get uglier as you go. But I remember one year they had this diagram. They had this big circle, and they had the ground was slanted, and they had a truck right here, and they had all these angles labeled, and the whole diagram was a mess. And somewhere in this diagram, I remember this, somewhere in this diagram right here, they had this truck right here, driving like this, and then they had all these angles, 30, and they had heights, and they had all these kind of things going on, and axis. All this stuff was just a total mess. And at the very end, it said, at what angle is the, they said like literally, paragraph of writing, and then it said, at what angle is the ground with the horizontal? 30 degrees. Literally, that's it. But I asked my students, I remember coming in, I remember looking at the problem and like, are you kidding me? Is it 30? Sure enough, it was 30. And I asked them when they came in, I was like, hey, who got number 25? Dude, that was impossible. I said, did you read it? No, man, it was so ugly, I didn't even look at it. Way to assume the position. And I get that, because that normally doesn't happen. Sometimes they really are that awful. But again, the design is to get you to, that's what I've found more than anything over the years in Algebra 2. There's some hard stuff out there. And there's some stuff you don't know. There will be. I mean, there's stuff that I've seen that I learned in graduate school in Euclidean geometry. About lattice points, and they'll throw it on an Algebra 2 test. It's not fair, but they're just trying to humiliate you again and take away your man or womanhood. But most of the time, if you enter these problems and you're like, okay, I'm going to assume I know. You know everything there is to know about a logarithm right now, all the rules. This is very short language. It can just be very confusing the way I write questions. So anybody got a question on your homework before I jump into some random problems today? And then your job tonight is to go home and do as much of this as you possibly can. Bring in good questions on Monday. Yes?
Okay, number 24.
You remember what it said?
No, but I just remember on the answer key, they switched.
You remember the page number?
Not, it was 490. 490 written exercise number 24.
490, 24?
You get about move right there so I can see a little bit better.
You can move there.
There.
Yeah, I gotta keep going distance. Too many people going down these days. Number 24, it was ln 1 over x equals 2.
I think. And then on the answer key,
Okay, let's just look at this. How do you get rid of, what does that mean right here?
Log E.
Log base e. So if there's log base e, how do you get rid of a log base e? You exponentiate with the e. So log e cancels. 1 over x equals e squared. Now, what do you do when you get stuff like 1 over x equals 5? What would you do to solve?
Multiply both sides by 5. By x.
Okay, you can, but do you know that if you have a fraction equal to a fraction, you can just flip both sides?
Oh.
Now look, if you multiply both sides by x, you get 1 equals 5x, and then when you divide by 5, you get x is 1/5. But that's the same thing as flipping that to an x and flipping that to a 1/5. So if it's me, I'm going to flip both sides, and I get x over 1 equals 1 over e squared. And I can stop right there, or you can write this as e to the negative 2, I suppose, but I would probably just stop right there.
okay. I think I just got confused with the key was just.
Yeah, well, sometimes it is, yeah. Well, another thing, though, don't confuse that with this. Like, for instance, you know that 4 is 3 plus 1. That doesn't mean I can flip each term. That's not true. It's if you have one number, one fraction equal one fraction, you can flip both sides. But that, like doing this, clearly, 1 plus 1/3 is 1 1/3. That's not 1/4, right? So don't do stuff like this, but if it is a fraction equal to a fraction, you can flip it. Just a nice little thing. Anybody else have any question or concern on anything we've done so far before we dive into this stuff? Okay, well, let's take a look. And stop me at any point if you don't get this, guys. This is for you. I know how to do these. I want to make sure you do. So what do you see in number 1? Again, do not assume the position. Assume you know enough. Let's see if we can figure out this mess. What are they asking you to do? Yeah, but what does that mean in this problem? What are they asking you to do?
Divide and multiply log.
Divide and what? Divide
Multiply.
and multiply logs. Did we just learn a way to multiply logs?
Divide the log.
Okay, so how do we multiply logs? What's our only hope?
Log.
Change the base?
Change the base.
Okay, check this out. This becomes
Log 3 over
log 3 over log 2. That becomes
Log
25
25 over log 7.
I tell you what, rather than write all this out because it's a lot to write out, when I look at these, I'm seeing there's a log 2 in the bottom, log 3 in the top, blah, blah, blah. But at some point I go, oh, there's a log 5 something on the bottom. That's going to probably cancel with something log 5 on the top. So why don't we write them as log 5s, like the 25 is log 5s, the 4 is log 2s, the 289 is log 17s, that is log 3s. Why don't we write them as the number to the power? And that will get us where we need quicker. So I'm going to change that 25 to just 5 squared. And then we'll deal with that 2 in a second. And then log 4 would be what?
2 log 2.
I'm just going to write it as log 2 squared, which is 2 log 2, but I'm not going to write log 4 over log 10 because already I'm in base 10 there. There's no need to do that. But if you did, what is log of 10? Log base 10 of 10?
1.
1. That's why I'm not putting anything there. All right, now what about this one? Log of 289, we said if you don't know that, that's log of 17 squared. And then what's log of root 5? Good. Lily said 5 to the 1/2. Now, right here, I'm going to write this right here, but then I'm going to show you how, if I was really doing it, I would not have written this. But I'm going to write it, log of 17. It's already base 10, so why bother putting it log 17 over log of 10, because log of 10 is 1. And that would be log of 3 squared over log of 7. Now I'm going to put that with a 1 on the bottom as well as that thing. Now you know to divide by a fraction, you
So,
multiply by a reciprocal. Now I would have done that and saved myself the trouble, so I'm thinking to take all of this and divide by that fraction, I'm going to multiply by the reciprocal. And then here to divide by that fraction, I'm going to multiply by the reciprocal. And then most people on this test, so that's gone now because I've moved it. Now most people on this test do this part right. And then it falls apart because this is what happens. They look at something like this log 5 term, and this, and they cancel the log 5s out, right? Or how about even better, they do this. They look at this log 2 squared and this log 2, and they cancel that 2 out and all of that. Kind of like they would cancel out like an x squared and an x, they'd cancel like that. But here's the problem. I do not have log 2 squared over log 2. I'm not canceling out one of the log 2's. I have log of 2 squared. So if I want to cancel out the log of 2, what I need to, or any of these, what I need to do is don't do what I just did. What you want to do is swing this 2 to the front, swing that to the front, swing this to the front, swing the 1/2 to the front, swing that 2 to the front. You want to do that across the board. And then when you do that, now the log of 3 and the log of 5 and the log of 2 are all freed up to cancel. Are y'all seeing that?
Why the bottom can't? Oh, because
Remember I moved those over here?
Yeah.
So they're not there anymore. So now I can come through here and go, all right, let's see this. There's a log 3. There's a log 3. There's a log 2. There's a log 2. And these powers are gone, right? I've got to get rid of those powers first before I cancel. There's a log 5 and a log 5, a log 17 and a log 17, a log 7. So it looked like this problem was completely random, but it was carefully crafted. Okay? And then you look at it, this other stuff, I can even cancel that 2 with that 2. What do I have left? 4
divided by 1/2.
divided by a half? What's 4 divided by a half?
8.
So this is not just a bunch of random numbers. This was carefully chosen stuff. All right? Now take a look at number 2. This one's a little weird because it says solve for y, and it's got y's and x's in it. But if it didn't have y's and x's in it, what would you do if it said just solve for y?
Get y on one side.
Okay, I eventually want to have y on one side as well, but it's buried right now in a bunch of logarithms. So can I go right now, since these are all base 10 logs, can I exponentiate? Why not?
What is that? Roll thing on it?
Because it says you can't exponentiate until you have one number on each side, right? Right?
Yeah.
Because the rule is not exponentiate each part, the rule is exponentiate each side. So let's get these sides cleaned up. How do I add 2 logs?
Multiply.
Keep the log, good, and multiply. So I'm going to go ahead and do that. 12xy plus 4y minus 18x minus 6. And then on the right, what do I do?
Same thing.
Same thing. To add 2 logs, keep the log, multiply 12xy minus 2y. Y'all with me? Now that I have a log on each side, now what can I do? You can exponentiate with the base of 10, or you can do the 1-to-1 property and just cancel the logs out. Either way, it cancels. Now what do I have left?
Is it like bases?
I have all that. Well, I want to solve for y, but look what happens immediately. That cancels. Are you with me? Remember, the logs are gone now. I guess I should bring this down. Trying to keep from writing another step, but we'll just do it. So don't cancel it up there. Now, these cancel, and that makes it really easy to solve for y. So how would you solve for y?
Bring that 4 over to
You can, it'd be negative. I'd rather bring it over here and make it positive, but it's your call. You totally can. That would give me 6y if I brought it to the left to make it positive. Then add the 18x, add the 6, and your last step would be divide both sides by 6, and you get y equals 3x plus 1. But at first glance, you're like, what the heck? And like, how am I going to solve for y with these x, y's in there? It's going to be so awful. But it cleans up. And if I just do what I know, like when I looked at this problem, I wasn't trying to visualize the end. I'm a rat in a maze. I don't know where I'm going. I'm just taking a cent and doing something with it. And one thing I know I can do is add 2 logs by multiplying. And then I look at it again. All right? Well, one thing I know I can do is exponentiate. You have to get past that mentality that you guys have your whole life in math. You've been the smart kid. That's why you're in this curriculum. You might not feel like it all the time in here, but I guarantee you, if you go to any other Algebra 2 class, the other 90% of the school, you would dominate. Okay? You'd be like king of the class. Okay? So even if you're struggling in here, just know that you're still in the top 10 percentile of the school easily, and you're not always now going to see where you're headed. It just doesn't work that way anymore. It gets harder. So don't get frustrated when you can't see the end. Just do what you know how to do, one step at a time. And then if it still goes south, you've done something. I can give you partial credit on stuff. I mean, if it makes any sense. All right, what about something like this? This is something we actually had in our homework. It said if log of 125, if log of 2 is this, which it is actually, except the decimal goes forever, but they're saying we're going to use just those 5 decimals. Could you simplify log of 125?
Yeah.
Now here, if you know how to do it, awesome. If you don't, is there anything else about a base 10 log that you know? Like is log base 10 of another value something you could answer? Like, because you might not know log base 10 of 3 or log base 10 of 4, but I also know log base 10 of 10 is 1. So I'm going to write that down. If it was base 6, I'd write log base 6 of 6 is 1. If it was base 5, log base 5 of 5 is 1. But that I know. So I'm looking for this. But I want to write it and have an exact decimal based on this approximation. So what is that equal to? Let's just get started.
5 cubed.
So this is log of 5 cubed, right? And log of 5 cubed is the same thing as 3 log 5. So I have a question. I don't know what log of 5 is. I don't. I mean, I do, because I may have or may not have memorized them. But I do know how to turn a 5 into numbers that I already have. 10 over 2. So if I did that, then what this allows me to do, because I know that, it allows me to take this and use a log rule to separate it. And what is log of 10 halves the same as? That's right, log 10 minus log 2. And now I can make substitutions because I know log 2 and I know log 10. So I get 3 times 1 minus 0.30103. And you can subtract that first and then multiply by 3, or you can distribute the 3 in and go 3 minus 0.90309, which gives you something like 2. I don't know. 9691 maybe? I don't know if that's right, but yeah, I feel good about it.
Oh.
Are y'all with me? But again, this 5 little thing shows up all the time. All the time. Because people just don't know it. So if you know how to go, oh, log 5 is the same thing as 10 halves, then I can split it up. At Vestavia, you're supposed to have this memorized. Believe it or not. If you don't have it memorized, you're going to miss problems, because they won't even tell you that. They'll say, round this to 3 decimal places or 4 decimal places. And you literally have to have that log base 2 memorized to be able to do it. I'm not going to do that in this class, although I might give you a bonus question and ask you about it. But I have it memorized to 5. I know log 3 to 3, and those 2 you can do almost everything with that you ever see the log from. All right, here's something interesting. Check this thing out. F of G of F of G of F of G of F of G of F of G in 1997. Now, what do you think's going to happen if I have this many F of G's?
Someone's gonna cancel.
Or there's going to be a pattern. Because they probably don't, this is a ciphering question, they probably don't want you to sit there and plug it into the G, then plug it into the F, and do that this many times. Although it's possible. But let's just get started. The first place they want me to plug it in is what?
G and F.
Expect to see just hardship and pain right here. So when I plug a 1997 into that, I get -1 plus log base 2 of 1997. And you know what? I have no idea how to simplify that thing, and don't want to. So I'm going to wait, okay? But I could if I wanted to. Okay, if I wanted to, how can you change -1 to a log? Log base 2 of 2 to the -1? Is that the same thing? And then how could I add these 2 together? Isn't 2 to the -1 the same thing as what? 1/2? How do I add these 2 logs? So when I multiply that times that, I get 1997 halves. Okay, it's a good start. That's the first into the G. Now what do I do?
Plug it into F.
Plug that into the F. When I plug it into the F, I get this. 2 to the, I'll tell you what, let's not.
Yeah, because
Check this out.
it cancels.
Let's just take that unsimplified and plug that into the F, and I get -1 plus log base 2 of 1997 plus 1. And now what happens?
The 2's cancel out.
And I'm left with 2 to the log 2 of 1997, which is 1997. So as ugly as it was in the front, when I plug into the second one, I'm back to where I start. So what does that tell you?
It's just gonna keep going.
For each time I go through G and F, I'm back to where I began. So this G and F, I'm back to where I began. This G and F, back to where I began. This G and F, this G and F, well, this G and F, I'm back to where I began. Now, if I had an extra G on there, I would write this, because that's where I am after a G. But after a GF, I'm back to where I began. Now, it looked really ugly on that first plugin, didn't it? But it really simplified on the second plugin. So again, don't assume the position. Don't look at this and go, oh, that's beyond my pay grade. Just try something, sniff around a little bit, and I think you'll find that a lot of these you can do, and they're really not awful. All right, what about, here's another similar one to that one we did with base 5. I want you to simplify log of 720, but all you know is log 3 and log 4. And this time they're not giving you a decimal. Like they didn't tell you log 2 is 0.301. They just told you about log 3 and log 4. Now, I would contend, if I tell you about log 4, aren't I really telling you about log 2? What is log 2 the same as? I mean, if I have log of 4, that's the same thing as log of 2 what? Squared, and what can I do with that 2? So, what is log 2?
Y over 2?
Y over 2. So I have log 2, log 3, and log 4 at my disposal when I need it. Now I'm asking you to do this, aren't I? Find log of 720. Do y'all have any idea how to take log of 720 and use 3, 4, and 2?
Wait. Oh, no.
Oh, and by the way, I also know what? Log of 10 is 1. Don't forget that.
Okay, could you do 8 times 3 squared? Or 3
Okay, so you're telling me that 720 is 8 times 9 times 10.
Yeah.
Right? So if I broke this up, what does it break up into? Log of 8, which is 2 cubed, swing the 3. Plus log of 9, which is 3 squared, swing the 2. Plus log of 10, which ends up being 1. And look, this is why I didn't like log of 4. Because log of 8 would have broken up into log of 4 plus log of 2, and I'm still going to have to know log of 2. So that's why, if they ever give me one that's not a prime number, I always rewrite it as a log of the prime number and use that. Because look, now I got to just substitute 3 times y halves plus 2 times x plus 1. So 3 halves y plus 2x plus 1. Not too bad? 6 look familiar? We just did one of those earlier, right? So what would you do first? With exponential with a 10. So if I said 10 on both sides, that log 10 cancels, and I'm left with log 2 of log x of 25 equals 1. Now what? 2 exponentiate. Now I get log base x of 25 equals 2. Now what? X exponentiate. Now I get 25 equals x squared. So x is, technically it's plus or minus 5, but why can't I use the negative?
Because you can log in negatives.
Because I can't have a base that's negative, so I toss that one out. Are you seeing these? I'm going to skip 7 and 8, let you work on them because I don't think they're that bad, and I think you'll be fine, as well as 9. 10, I want you, that's similar to the one we just did. By the way, on number 10, this is one like we just did with 720, log of 720, but this time it's base 2. Is there another base 2 value you know that they didn't talk about?
2.
So log base 2 of 2 is 1. So when you start breaking that up, you need to be able to break it up into 3s, 7s, and 2s. And if you can do that, you're going to be okay. And sure enough, 504. Threes, 7s, and 2s. And if you can break it up into 3s, 7s, and 2s, you're going to be home free. Right?
Right. Yeah.
Okay, what about this, number 11? We talked about these at the beginning of class.
Well, wouldn't the, so you could move the 3.
Okay, so that if I move the 3 up, that would give me E ln of 10 cubed.
And then doesn't the E and the ln cancel because
Yes.
it's log E?
Because ln is log E, right? So E log E cancels.
So then you just have 10.
And I got 10 cubed, it's just 1,000. Right? What do you think about number 12?
For that one, you can.
So like when you add logs, keep the log, multiply. Negative 3x plus x squared. And then what would your next step be? 1 to 1 or exponentiate. Either way, you just get that. And then at this point, what would you do?
Factor.
Set it equal to 0, factor it. And remember, do negative answers work?
No.
Possibly.
Oh, yeah. Yes.
Check this out. This is why they did it this way, I think. I get x minus 5, x plus 2, and I get 5 and negative 2. But look, a negative 2, when I plug it in, becomes positive 2. When I plug it in, becomes positive 5. It works. Positive 5 doesn't work. So don't make the mistake of always throwing out negative numbers, or you're going to miss easy stuff like this. And I know I said in number 14 you need to have log of 2 and log of 3 memorized. Again, I'll probably put it as a bonus question because on an AP test, on a Vestavia Hoover or whatever, they'll just say, what's log of 12? Round to 3 decimal places. And if you don't have that memorized, I just memorize these two, the only ones I know. Because think about it, you can make log 4 from log 2, you can make log 6 from log 2 and log 3. You can't make log 7, but you can make log 10 well, you already know log 10, right? You can make log 5 from 10 over 2. So you can make 12 from 2, 2, and 3. You can do all kinds of different things, which is what they're asking you to do here, right? So if log of 12 is the same thing as log of 2 times 2 times 3, can you break that up? Or 2 squared times 3? You can break it up into a log of 2 squared, or 2 log 2, plus a log of 3, and then you can make your substitutions in there. So this is enabling you to do a whole lot if you have a couple of them memorized, but on your test, I will not make you. I'm going to let you play around with some of those. These all look very familiar. All right, 19. Let's see how far you've come today. All right. And again, you gotta get past that mentality of, I don't know where to go, I don't know what. Is there one thing you can do? I used to do this trip out in Northern California. We would have these people hike up Mount Shasta, and we would bring all these kids out there, and we would get them going, and this is back in the 90s. And I remember, actually, dang it. Anyway, there are people in your class, I did it with their parents. And their parents were like campers of mine. And I'll just tell you, Chandler's parents, her dad was hiking up with us. And I remember, and my wife and I, we weren't married at the time, but we were dating and we were out at the ranch. We were both running this camp. And I remember there's a point where kids would just collapse on the side of the mountain. They're like, I can't go any further. And we're like, really? Not like one step further, you can't go. They're like, no. I was like, dude, get up and take one step. And they just get up. And it's hard to breathe up there. When you're like 13,000, 14,000 feet, it starts getting harder to breathe, especially if you've been hiking 7 miles that morning up an incline like this with ice picks and ice axes and crampons. And they would just take a step, and I'm like, you took a step. You got another one in you. And take another step. And after about 5 or 6 steps, I'm like, looks to me like you're not finished. And those kids would eventually get to the top of that mountain. It's really hard. It's probably the hardest thing I've ever done, is hike up that thing. But the point is, there's more in you. You just have to try something. You have to risk another step. And when you're looking at these, it might not be as daunting as Mount Shasta, but it's possible. Just try something. Is there one thing you know how to do here?
We can do log x over log 5.
So you saw multiplication, and you thought change your base rule.
Yeah.
So see what happens. Log x over log 5, log 5x over log x, log y over log 5x, and then this is just what?
Log
4 log x over log x, which already cancels and just leaves you 4. Now, does anything here cancel? The log x's cancel. The log 5x's cancel. And what are you left with?
Log y over log 5.
Log y over log 5
Log 5.
is
y
just a 4.
equals 4.
Now, at this point, I could do a couple of different things, but let me ask you this. Is there a way to rewrite that back into a log?
Yes.
What would it be?
log base 5 to the y equals 4.
Log base 5 of y is 4. It looks to me like a pretty simple log problem at this point. What would you do?
5 to the 4.
And since we all know our powers. Now, did I know where I was going when I started working this problem the first time? No. but I knew one thing I could do. I could take one step up the hill, and if you can take one step, you're not finished. I just didn't assume the position and take a beating, right? So try something. Even if you don't know where you're going. Again, park the clouds, let the sun shine down, right? And light the way for you. What about 22? What time I got left? Not much.
You're looking at 32.
2 seconds, 2 minutes?
Enough time. Yes, 2 minutes.
Is there anything else that's more interesting than that? All right, how about 20? How about 20? Oh, no. Some of these are brutal. 26 is pretty tricky. I want you to give it a shot. Oh, 27. Anybody got any ideas?
Well, you can do 25 equals 5 squared.
How about this? Is there a way to change 1/2 into a log? How do I, it'd be what? It'd be a log base 5 of 5 to the half, wouldn't it? Yes, no?
Yes.
And then how do I subtract logs? So log base 5 of root 5 over root 2.
Oh, wait, this makes sense.
I'm just trying junk, right? And then I still have the space of 25. Now, what do I need?
The 5, well, 5.
Those to match.
The 5, yeah, so you can change the 5 squared.
So I could change 25 to 5 squared,
And then you can just bring that up.
and then I can do power to a power, multiply, right? And if I did that, wouldn't I have 5 to the 2 log power?
And then you get
And then what can I do with that 2?
25 over, or you can take it and make it 25.
Swing it up to all of that? Then what happens?
The radicals go.
And what am I left with?
Like
Now, I didn't even do it that way on my homework, but it's probably easier this way. I mean, on the key. And there's a lot of different ways I could do it.
Where did you get the root 5 from?
5 to the 1/2 power.
Oh, yeah, the.
Hey guys, expect to be tricked up by some of these. Do the best you can, look at the key, and bring me good questions on Monday. And y'all enjoy your weekend.
Well, 2 more lessons.